One of the most common Unreal Engine questions I get is why use event dispatchers when you can use interfaces, or vice versa? And I was always confused by this question because event dispatchers and interfaces serve very different purposes, and they should be used together instead of one or the other. So in this video, I aim to teach you the difference between interfaces and event dispatchers, when to use them, and most importantly, why use them at all. Also, if you have any questions like the ones I'm going to answer in this video, I wanted to let you know that I created a really cool learning tool, a chatbot that contains all of the information from my YouTube channel and can answer any question you have when following my tutorials. It's usually only for my Patreon members, but now I created a free trial for everyone, no credit card required, just a valid email address, and your honest feedback about it is really appreciated. Link to sign up to the free trial will be in the description. Now, let's continue with the video. In game development, creating modular and flexible systems that are easy to extend and maintain is crucial. Interfaces and event dispatchers both help you communicate between different parts of your game to prevent a tangled mess of dependencies. That's why people often see them as competing tools, but instead they can actually complement each other. So let's see how, starting with interfaces. An interface allows you to define a set of functions that describe how a class should behave, but without implementing them. Then any class that uses this interface will provide their own unique implementation. So it's not a method of sharing the implementation of functions. There are other ways to do that. It's a method of sharing structure between different classes. For example, let's say you're building a game where you can interact with different objects, like talk to an NPC or pick up an item. So you want to create an interact function that when you press a certain key, it interacts with that object. But interacting with an NPC does something different than interacting with an item. So they have a unique implementation of that interact function, but both need to have that function. So to enforce that they do have that function and that function takes in a certain input and gives a certain output, you should create an interactable interface and define that function in it. And then any class that adds this interface, like the NPC or the pickup class, will provide their own unique implementation of the interact function. So why do we do this extra step? Well, we do this so that we can treat different classes that implement the same interface similarly and enforce a consistent behavior across these different classes. So let's look at a practical example. So I'm going to right-click and search for interface. And I'm going to choose Blueprint Interface, and I'm going to call it BPI Interactable, and open it up. So this interactable interface, like I said, here we define only the function definitions. So I'm going to define one function called interact. I'm not going to have any input and output for this function. And of course here you should define all of the functions for an interactable object or class. For example, I can have another function that's called can interact, and this will return true or false whether I can interact with that item or not. Maybe an NPC is busy, I can't interact with them, or an item is not mine, so I can't interact with it. But you get the idea. Here you define all the functions, what it means to be an interactable. For now, I'm just going to stick with one interact function to make our example easier. And I'm going to compile and save. And here I have two classes already, an NPC and a pickup. They're just empty classes, empty actors with a mesh inside. So I'm going to go to my NPC class, and over here in class settings, I can see interfaces here, implemented interfaces on the right. So I'm going to search for my interactable interface, and I'm going to add it. What this will do is automatically on the left here, give me the interact function and ask me to implement it. So I do that by double-clicking on it, and it will create an event for it. If it had an output, it would have created a function for it, but because it doesn't, it creates an event. Now here I define what interacting with an NPC means, because here we're in the NPC class. So maybe I can have the NPC face the player, open quest menu, whatever. For now, for this example, I'm just going to print interact NPC. And now I'm going to go to my pickup item and do the same thing. So go to class settings, under implemented interfaces, add the interactable, and double click on the interact function to implement it. Now here, this is the interact of a pickup. So maybe you want to destroy the object, add it to the player's inventory, and so on. Here, I'm just going to print interact pickup. Great. Now we just defined an interface and implemented it in two classes, but we haven't used the interface functions anywhere. And this is where the magic of interfaces comes up. It's how they enable communication between different classes. To show you what I mean, let's go to our player and do something very simple. So in my player, when I press X on the keyboard, let's do a sphere trace. So I'm just going to do a sphere trace from my player's location. And I'm going to do, say, a radius of 150 around me. And then I'm going to check if I hit something. So I'm going to do a branch here. If this is true, that means I hit something. And I'm going to break the result of whatever I hit to get the actor that I hit. So it will be here, hit actor. Now, this part is very important because right now I just hit an actor. And I'm in the player class, so I don't know anything about NPC or pickup. I just know that I pressed X on the keyboard and I hit something of type actor. And I want to see if I can interact with it. I don't know that there is an interact function on the NPC that opens up a quest menu. I don't know that there's an interact function on the pickup that adds the item to my inventory. I just know that I hit an actor, so I want to see if I can interact with it. And that's the cool thing about interfaces, that I can just call the interact function, and you'll see here that it's from the BPI interactable, on any actor. It doesn't have to be of type NPC or type pickup. It can be literally any actor. And you'll see here that it says that this does nothing if the target does not implement the required interface. So this is the great thing. I can try to interact with it. If they don't have the interface, nothing will happen. And if they do have the interface, if this is an NPC, if this actor is an NPC, it will call the interact function from the NPC. And if the actor is a pickup, it will call the interact function from the pickup. All right, now let's play and see how this looks like. So I can go over to my NPC, press X, and on the top left, it says interact NPC because I'm interacting with the NPC now. And if I go to my pickup and I press X, it calls interact pickup because it's calling the interact function from this pickup class. So it does exactly as we intended. Nice. Now, if you don't really appreciate how important this is yet, let's see what happens if we don't use the interface. So let's go to our NPC now and implement a new custom event, the one that we were going to add to our interface initially, called can interact. Oh, actually, let's make it a function because it's going to return a value. So let's implement a can interact function. And this function gives us a value true or false. Let's say it just returns true by default and prints can interact NPC. So right now I've implemented this function directly in the NPC and I didn't add it to the interface. And I can, of course, copy it and paste it to my pickup and just change this to interact pickup. So now I have the same function in both the pickup and the NPC, but it's not in the interface. So back in my player, if I want to use this function now, so let's say before calling the interact, I want to first check if I can interact with this actor or not. Well, I can't just pull off of the hit actor and call can interact. It's not going to appear because can interact only exists on the NPC and the pickup, and it doesn't exist on the hit actor, which is of type actor. So what I have to do is cast my actor to an NPC, and this cast will succeed if this actor is of type NPC, which is a child of actor. And then I can now call can interact on it. And of course, if this cast fails, so let's say now if it's true, if I can interact, then I do the interact. But what if it fails? Then that means this wasn't an NPC. So then I try to cast it again to pickup on fail, and then try to call can interact on pickup. And then only if this is true do I call the interact function ultimately. And of course, if you add a third class that implements the interact interface, you have to then on fail here, cast to that class, and so on. So as you can see, this doesn't really scale and it's very messy, as with just doing one call to an interface function. Now, not only that, but I want to show you a bonus tip, and you might hear this a lot, that interfaces help you avoid casting and that casting is bad and you should avoid casting at all costs. Now, casting isn't always bad. I want to just explain this so that this rumor doesn't keep circulating. Let's first remove all of these casts, and I'm going to show you something. So I just now have a call to an interface function, and that's it. So if I check my player here, I'm going to right click and I'm going to search for something called size map. Now this size map, and I'm going to select here memory size, this shows me how much space in my memory, in the RAM, does this player take up when it's loaded. So right now it says here that the player takes up 65 megabytes in memory. And you'll see here most of it, it's texture, there's the engine skeletal mesh itself, and so on. Now, if I cast to any class, and I don't even have to connect it to anything, if I just put a cast node here, and I compile and save, and if I try to check the size map again, you'll see that it doubled now. And you'll see that when I load the player, I have all of the stuff that I had before here, but now I have everything that's in MPC is going to be loaded as well. That's because when you cast, you tell the engine that this player class depends on an MPC class to exist. So if this one is loaded in memory, this should also be loaded in memory. And that's why people will say avoid casting at all costs. But that's not really true. Be smart about it. You can cast with classes that you know are dependent on the player. So let's say, for example, the player is holding an axe, and the player always has this axe, or a camera, for example. Then casting to this axe or this camera class is not going to cause anything else to be loaded into memory because it's already loaded into memory. You know that the player always comes holding an axe, so it doesn't matter if you cast to it. And actually you should probably be casting to it because you're saying that these two classes depend on each other. So just be smart about it. If you are casting from an AI controller to the enemy AI that it's controlling, that's fine because they always are loaded together, but don't cast from classes that don't depend on each other. That's the bad thing. So in general, use interfaces when you want to enforce a consistent set of functions across different classes, allowing other classes to treat them the same without directly referencing them, thus adding structure to your game, creating separation of concern, decreasing dependencies, and decreasing memory usage. Great. Now I think you have a good grasp of interfaces, when and why to use them. Now, what about event dispatchers? Event dispatchers are used to broadcast events from one object to another to notify that something has happened. This is very useful when you want to wait for something to happen in one object before doing something in another object. For example, you want to update the player's health bar widget when the player takes damage. Well, you can, of course, keep updating the health on tick of that widget, and when the health changes, then the widget will update as well. But then you're needlessly checking the health of the player on every tick when you know that things aren't changing, so it's really a waste of resources. Now, using event dispatchers, you can have the player dispatch an event, say something like on damage taken. Then the widget can bind to this event. And when it's dispatched, only then will the widget update the health bar. Now, this is one of the most common use cases for event dispatchers. But my favorite use case, which I've shared in many previous videos, is using event dispatchers to build modular actor components that aren't coupled to any specific actor. For example, let's say you want to build a health component that can be added to any actor, allowing it to keep track of its health and take damage and die. Now, event dispatchers are extremely useful here, and let me show you why. So I'm going to create a blueprint class of type actor component and call it a health component. And in this health component, I am just going to add two things, a health variable, which is a float, and a take damage function. Now, this function will just get the health value and subtract, let's say, 10 from it. And then it wants to check if this actor is dead or not by checking if this health value is less than or equal 0. And if this is true, that means that this actor using the component is dead. But we don't want to implement the death logic here because the NPC can be using this component, the pickup item can be using this component, and they will all have a unique death behavior. So the actor component should never assume what happens on death. Instead, it should just dispatch an event. So on the event dispatchers here, I'm going to create an onDeath event, and I'm going to drag it here and say call. So now this actor component is just saying or signaling that the actor should die, and it should do whatever unique implementation it has on death. And here is where people get confused between event dispatchers and interfaces. But before explaining why there's a confusion here, let me just continue with the example and show you how it's used first. So now if I go to my player and I add this health component just by going on the components here and searching for health component. Now if I click on the health component, and the nice thing about event dispatchers is that if I dispatch any event from a component, I'll find it in the list here on the right. So I see that my onDeath event is already here, and just by clicking on the plus icon next to it, I bind to it and I create an event. This is the same as getting my health component, searching for bind on death, and then creating a custom event here. These two events, this one and this one, are identical. The only difference is here you have to bind manually, and you have an option to unbind as well when you no longer want this event to be dispatched, or you no longer want this event to be called when onDeath is dispatched. And with this method, you can't really unbind. So that's the main difference. And then I can implement my unique player death here. So I can say, yeah, whatever, player dead. And of course, if I go to any other actor and implement the health component as well, same thing follows. So this is the NPC. They can implement their own unique onDeath event and just print death NPC. So this is where the similarity is between event dispatchers and interfaces, is that they allow for decoupled communication. Now, the player doesn't need to know anything about the health component other than that it dispatches an onDeath event. The health component doesn't care what happens on death, it just signals that something happened. Same as with the player here, doesn't care what happens on interact, they just interact, they call the interact interface function. Now, let me show you how the same behavior for onDeath here can be implemented with an interface, and again, why people get these two confused so often. In my health component, instead of dispatching an event, what I can do is I can get the owner of this actor component, which if in the player's case will be the player, in the NPC's case will be the NPC, and I can call a death interface function. So if I have a new interface, just like the interact here, I can call interact. So if I have a new interface called, I don't know, damageable, and the interface itself has a death function, well, I can just call the death function here instead of dispatching an event and then listening to it. Now, these are two different ways of doing the same thing. Personally, I prefer the event dispatcher method for something like this, and let me explain why. Now, with the interface method, so let's assume here that I have a interface death function being called here. So if I am calling this function instead of my event dispatcher, the health component still makes an assumption. It makes an assumption that the owner implements this damageable interface and has a death function and doesn't allow for the owner to do anything else. You can't extend it. You can only implement a death function and that's it. But with the event dispatcher, any actor can use this interface. Can use this actor component. So even the pickup, maybe the pickup doesn't have health. Maybe the pickup doesn't have a death function, but wants to have a health component for some reason. You can still implement onDeath, but you don't have to implement the damageable interface. So that's the main difference. I feel like this offers more flexibility. You can use this component for more cases, whereas if you have an interface function called here, then the component always assumes that the owner will implement this interface. But as with anything in software, there are pros and cons to each approach. There is no right and wrong. It all depends on your use case. So to conclude, event dispatchers allow one part of your game to send out signals to other parts so that they can react to it. And this is particularly useful when you want one part to wait for something to happen before doing something. Like you're waiting for the player to pick up an item before opening a door. Instead of constantly checking, did the player pick up the item, did the player pick up the item, you wait for that event to happen and then only then take action. Using Event Dispatcher makes your code more flexible and easier to manage because it allows different parts of the game to communicate without assuming what each part needs to be doing. And interfaces are useful for enforcing a specific structure across different classes to ensure that if a class implements an interface, it's like signing a contract. They agree to follow a certain structure or implement a certain amount of functions. This allows you to treat different classes similarly without assuming what this class needs to do as well. This improves memory usage, makes your code more flexible and easier to maintain, and allows you to easily remove one part of the game and replace it with another. If you're still confused or you have more questions on this topic or any other topic, leave them in the comments below and I will answer all the comments as I always do. Which also actually trains the chatbot that I told you about in the beginning of the video, because every comment or every answer that I give is uploaded to my chatbot's database, and it gets smarter the more the community engages with my videos and the more answers I give. I'm very proud of having built this chatbot, so I'm very excited to share it with you all for free during this trial. Link to the sign up will be in the description, and if you want full access to the chatbot, you want full access to all my courses, project files, assets, and a lot more benefits, you can sign up to become a full Patreon member. You'll be supporting me, supporting the channel, and making all these videos possible. As always, thank you for watching, subscribe to learn more about Unreal Engine and game development, and I'll see you in the next one. Boom, 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 ba-da-da-da-da.